Here's a photo that I love to put in front of everybody, any kind of target audience, to say, that's not a drainage problem, that is a relative humidity problem. When you cross that 60% mark and it sustains at that level is when you start to get all your fungus and your black mold starts to set in, your corrosion starts to amp up and accelerate, the attraction of termites. If you're looking at the photo underneath the vertical crack repair, this is one length of the foundation with
holy crap.
Yeah, pushing in concrete is considered cancer in concrete. It starts at a slow pace, and depending on your environment changes, it starts to accelerate and eventually pushes the concrete around it. Relative humidity is something that seldom gets checked, goes unnoticed, and is not always in the forefront of everyone's thought. But it's very important, especially in a confined space like an attic or a crawl space or a basement. So we find out how much moisture content is there in the ambient air in that confined space and see if it fits within the certain limits, especially for the Bay Area. If you're under 40%, that's the optimal range. But again, we have to live in the real world. A lot of times reality is much different from what theory wants it to be. So anywhere between 40% and 60% of relative humidity is still acceptable. When you cross that 60% mark and it sustains at that level is when you start to get all your fungus and your black mold starts to set in, your corrosion starts to amp up and accelerate, the attraction of termites would be super high, damages to the wood because of all the moisture content in the air in the crawl space or any confined space for that matter would be much more fast-paced in that environment. So we make it a habit to find out the relative humidity in a crawl space. The higher relative humidity, the more chances for damage, the more chances there is a drainage issue. And sometimes there is a difference between a moisture problem and a water problem. A water problem is typically associated with a drainage issue. A moisture problem is associated with your, water vapor in the air of the crawl space that doesn't cause a standing water per se, but starts to affect the other areas inside a confined space. So we take a hygrometer, we put it in multiple spots inside a crawl space or a basement, let it stabilize. And sometimes you would have interior foundations which kind of close off the portion of the crawl space. So we make it a habit to put it in different spots so we can find out what the maximum is, what the crawl space average is, and if there are any further recommendations to lower that relative humidity inside the crawl space. What are things that could affect the relative humidity? The outside temperature and the weather conditions, the interior temperature conditions inside a basement or a crawl space, because there is always a siphoning of the moisture from a higher concentration to a lower concentration. So if you have sprinklers spraying all the time on the outside, the moisture content on the outside, immediate outside, is quite high, and the moisture content on the inside the crawl space could be low. And then you could have, because of the temperature and the pressure difference, you could have a siphoning effect of the moisture going into the crawl space. If you don't have sufficient ventilation for the crawl space or the basement. That's why it's always important to check how many crawl space vents you have and if they are sufficient, and if you have cross ventilation. Per code, you need 1 square feet of net vented area for every 150 square feet of floor plan area. So that the same thing applies for the roof attic, the same thing applies for a crawl space or a basement. There are unvented crawl spaces, unvented attics. In those situations, you have to make sure that the moisture is trapped within the soil and it does not interfere in the crawl space with respect to the foundation or the wood framing or any other hardware for that matter. So these are situations where you could have a trapped moisture that causes the relative humidity to go up. When you have large ducting and insulation in the crawl space, that tends to hold on to this moisture and it increases the relative humidity and keeps it at a higher and sustained level. So these are things that we look for. And here's a photo that I love to put in front of everybody, any kind of target audience, to say, that's not a drainage problem, that is a relative humidity problem. And look at the situation, the condition of that beam. It has a cable strapped to it. It is not a built-up section. We're not looking at a top section and a bottom section above and below the cable. It is a single 4x6 beam that supports the floor at every 4 to 5 feet spacing. The beam is supported continuously at regular spacing by these metal screw jacks, or metal jacks that can be adjusted. And it wasn't because the screw jack was adjusted. It was because of so much moisture that the jacks corroded so much and started pushing up. And the moisture in the soil started pushing up the pier and the jack up, that it propped up everything to push that situation. This is one condition in a crawl space in the Almaden region of San Jose. And there were multiple situations like these in this exact crawl space. This was an inspection back in 2020, I believe. I did this inspection. We did quite a bit of work here to control the moisture, did a lot of fixes for the wood framing, replacement of the wood framing in most cases. The screw jacks were replaced with pressure treated wood posts to get more life out of them. A lot of times people are conflicted between, should we use a pressure treated or preservative treated wood post, or should we go for a metal jack? And the cost of using either of those components practically comes down to almost the same, but it depends on how you want to adjust them, how frequently you're going to have people inside the crawl space, and how much movement you expect to see in that particular situation. So in this case,
why did they put a jack in this case? I don't understand. I have never seen a house with jacks in it before. It's usually, basically made from basically wooden posts.
Screw jacks or metal jacks or adjustable jacks, as they're called, or smart jacks, or in today's terminology, they're not uncommon. You see them in 3 or 4 out of 10 crawl spaces. The remaining 6 or 7 out of 10 crawl spaces have wood posts supporting the floor beam. Metal jacks are, you could see a lot of them in Santa Clara. You could see a lot of them in Milpitas area, around late 60s and the entirety of 70s. I think engineers had this, let's try out some metal jacks to see, because at a capacity level, these metal jacks are much higher rated than what a 4x4 or a 4x6 wood post would be able to handle. And because it's metal, it won't immediately, even if it goes through a good amount of corrosion or damage, it can still support the weight that comes down on it, because having something that can support 2 times what's required versus having something that can support 10 times what is required is the difference that we're seeing, between a wood post and a metal jack on an illustrative purpose, right? So people thought, okay.
And I assume that they put the jack there so they can adjust the settlement in future.
Exactly. And the wood posts do the same thing. It's easy to swap out a wood post, but the metal jacks, you can actually crank them. You can actually adjust them in place as long as they have a corrosion protection sleeve and they're not significantly corroded. And most of these jacks will have a base plate that is corroded, would not be properly fastened or bolted down to the concrete pier, or may not be connected to the wood beam that it's supporting. So when there's an earthquake, they start to tilt and rotate and they just go off plumb. So it would have to be adjusted back in place and connected properly. But they do serve the same purpose as a wood post. And it's not uncommon to have them or find them in a crawl space in the Bay Area. But again, higher relative humidity can do that to any crawl space, any situation where you have.
Do they put metal jacks these days in constructions?
Yeah, absolutely. There are companies that make these jacks that come with a sleeve that gives you the protection. They're usually galvanized jacks that come with an additional sleeve that protects it. The way that these sleeves are put on these jacks is a little different for different manufacturers. Sometimes I have been able to pull the sleeve up and down, which basically serves no purpose. Even though the jacks are galvanized themselves, it'll have a certain amount of resistance, but the sleeve is there to protect it and properly, attached to that jack. But otherwise, they're a pretty good system. You find a lot of manufacturers up in the Northwest region. But again, it's not uncommon. It's not one step less than using a wood post. It is totally okay and fine to use these support systems.
Okay.
Right. So these are the kind of damages that you would see when you have a higher relative humidity inside crawl space. And solution or prevention would involve installing a vapor barrier or a crawl space barrier or a liner inside a crawl space, or you could even do it in a basement. The most important thing in this situation is not just putting a plastic sheet on the floor of the crawl space. It is about sealing it properly against the foundation, against the piers, against interior foundations, and any other obstruction. So our goal is to make sure that the moisture from the soil does not creep up into the crawl space environment. So we put a 6 to 10 mil thick plastic sheet that is heavy duty, that is sealed along the seams, and is sealed along the edges of the foundation, at least 6 inches from the above the soil on the foundation stem wall, or it can be the piers. So in this situation, you can see that they've actually sealed it all the way to the bottom of the post, and they've also sealed it all the way to the basement, depending on how much moisture or you're seeing creeping up into that system. But typically, a 6-inch minimum is recommended. A lot of times we see them done all the way to the top of the stem wall, and that makes inspecting the foundation a little difficult. So we will have to cut off the top part of it, inspect it, and then reseal those portions. It is possible. It is doable. We can still inspect these situations by cutting and then resealing these portions. So in case you encounter one of those, what to do, who to call.
Why do you want to seal the place? With all this plastic? I don't understand. Are you trying to prevent the moisture from going into the crawl space to prevent any interaction with moisture with the posts and beams over here?
Exactly.
Is that
so water or moisture interaction with wood, water or moisture interaction with metal, water or moisture interaction with concrete, water or moisture interaction with soil. These are the 4 commonly noticed interactions of water or moisture with building materials that we see in residential construction in the Bay Area. And any of those things, when you have that happening in an excessive fashion, you would find it resulting in some kind of an issue. So we try to monitor and control and mitigate these interactions as much as possible to minimize or slow down the damage process. At the end of the day, water can find its way, moisture can still find its way somehow, but we try to stop it and slow it down.
Basically, to regulate the relative humidity within the crawl space.
Exactly.
Okay.
So that you can keep it under in the acceptable range, or in your best case scenario, you can keep it under the optimal percentage of 40. So if you're under 40 percentage, that's super nice to have that situation. In summer, your relative humidity is expected to be much lower. During the rain season, relative humidity is expected to be higher, but if it sustains above 60 or 65 percentage, and that's how it's always going to be, that means almost 4 to 6 months of a year you're going to have that higher relative humidity in the crawl space, and that's more than enough for all these damages to start happening.
Okay.
And when you see plastic sheets that are torn up, that are just laid down on the floor, that is not a crawl space liner. That is not a proper vapor barrier. And people misunderstand that, I have plastic sheets, so I don't have a moisture problem in my crawl space. I'm sorry to say, I don't think that's necessarily true.
Okay.
Using a dehumidifier is another good option, but the common misconception is that I put a dehumidifier in my crawl space, I don't have a relative humidity problem. I put 2 of them, I put 3 of them in my crawl space, I absolutely don't have a problem. I'm sorry, not necessarily the case. When you can prevent the supply of moisture into the crawl space environment first, and then you put a dehumidifier system to collect the remaining moisture, you can either collect it in a jug that comes built into that system, and you would have to empty out the jug more often, or the more sophisticated system that is in use today is it comes with a drain line that discharges the water out and away from the structure. So that would be a better system, provided you have mitigated the supply of moisture into the crawl space. If you just put dehumidifiers in a crawl space, that is not going to regulate the moisture content, more moisture condition inside a confined space. Even vents, crawl space vents, come with the humidity or temperature-based fans that kind of circulate the air, bring the dry air from the outside in, and then siphon out the damp air outside. Again, if you don't have the crawl space sealed properly first, you're not actually making a huge change by these installations. So it's important to understand when and where to install these dehumidifiers and to find out if they are actually going to serve the purpose that you want it to serve before you spend all that money into that situation.
Okay.
All right, now we're getting into the foundation part, which is, see, all of these things that we talked about, everything, it never felt like we were not talking about foundations. It was always about foundations, but anything and everything that could affect it. So drainage is equally important in understanding what's going on and how it can affect it, as it is important to understand how the structure behaves and if it's sufficient to handle the loads that it's been subjected to, right? So in this illustration, we're just showing a simple raised foundation. You are at the perimeter on the ends. You see a CMU, a concrete masonry unit, as used as a stem wall with a spread footing. And then on the interior for a floor support, you have the wood floor beam or a girder that is supported by a pier and a pier footing. It's just an illustration to show you how a raised foundation is going to be in typical situations. Common cracks that we see in concrete is vertical crack or horizontal crack. Transverse cracks are most likely also related to vertical cracks. It depends on what kind of forces the foundation are subjected to that causes that transverse or diagonal cracking. Sometimes shearing off effect of the foundation can also cause a diagonal cracking in that situation. Corners of the foundation are subjected to more stresses a lot. So corner cracking also happens. They appear in a vertical fashion, but they're different from vertical cracks. And then we all the time deal with poor quality concrete, be it the mix of the concrete, it can be an aggregate issue, it can be a chemical breakdown issue, it can be a moisture related issue, or it can be a spalling or deterioration or delamination in the concrete, or a number of things that the concrete foundation is being subjected to. So we're going to talk about all of these things in a little bit of detail. This is a typical vertical crack in a concrete foundation. You can see the white spots. That's basically the efflorescence indicating that moisture has been seeping through these cracks. It's just an evidence of the crack allowing water to seep through or moisture to seep through. Vertical cracks are typically on a B list of the priority. And the reason is because apart from letting water through, if these cracks appear at an anchor bolt location, then they can compromise the capacity of the anchor bolt, because the anchor bolt is as good as the concrete that it is embedded into. If you have a crack, then you would have to fix it or infill that crack to get more strength so that the anchor bolt can be in continued service. Typical recommendation for vertical cracks is to inject it with epoxy. We use mostly Simpson products in the Bay Area here. You can actually, the more important thing is to pressure inject epoxy into these cracks. Oftentimes I find that there's a surface application of epoxy to seal, to kind of cover the crack. Covering the crack is not exactly sealing the crack. You have to chase it, you have to clean it, you have to make sure that the debris comes out of it. And then you fit ports based on the width of the crack, and then you pressure inject. There's a specialized epoxy gun that you would have to use to pressure inject the epoxy so it overflows out of that crack after it fills the entire crack, the valley or the depth of it. And then you just basically prep the surface. It's a two-part component. There's a bonding agent that goes in, and then there's the actual epoxy that goes inside. That's your common application, and it's pretty simple, straightforward stuff. Prevents the water from seeping through back again, prevents the foundation from separating apart, or if you're on a hillside, you can also experience differential settlement. If the crack is wider than 3/16, or even, you get towards 3/8 of an inch in terms of the width of the crack, we also employ stitching the foundation together by means of using a rebar staple or a metal plate and bolts connecting the two concrete sections that are separating. You could epoxy and then stitch them together, or you could bring it out and pour a section to hold these things together. There are multiple applications.
Was this one straight foundation, or was this a lateral foundation? That was.
This is one straight foundation. If you're looking at the photo underneath the vertical crack repair, this is one length of the foundation with
holy
one
crap.
Crack. Yeah.
Holy crap!
So the
That's
epoxy
a lot of
application
crack.
is just here. No. The epoxy application is just right there. That's the height of the foundation. This is the length. If you're inside a crawl space and you're facing the stem wall, that's what it looks like. This is quite typical. Any foundation that you'd look at in the Bay Area, it's going to have at least a minor vertical crack, and that's very common.
Okay.
On the right-hand side, you see a corner crack. Like I said, the corner crack is a little different from a typical vertical crack. We have to stitch the two foundation sections together. We call that a diamond repair. It's a diamond concrete section that's poured. We use rebar, epoxy doubled rebars to bring these sections together because the forces concentrated on corners are quite heavy. And then you also have anchor bolts on either side of the corner. So you want to make sure that the concrete section you're pouring is able to restore the foundation in that area. That is a horizontal crack that you can see from inside a crawl space. You can also see that there's standing water. Every time you see standing water against the foundation, we check for horizontal cracks. Every time you see a water softener that is against a foundation, I move the water softener to see if there's any horizontal crack or any corrosion in the concrete foundation behind the softener. Even if it is a softener that was installed a few months ago, I make it a habit to check behind the softener because the system that they use to soften down the water, the chlorinated system, you can still have a little bit of diffusivity from that entire system. It's a sealed system. Yes, I totally understand that. But I've seen horizontal cracks behind water softeners, mostly old water softeners, all the time in my inspection. And I make it a point to move them just to make sure that there's no cracking that's hiding behind the softener. Primary cause of horizontal cracking, we talked about them. 9 out of 10 times, it's rebar corrosion that, like I said, corrosion in concrete is considered cancer in concrete. It starts at a slow pace, and depending on your environment changes, it starts to accelerate and eventually pushes the concrete around it, causes the horizontal crack. This always goes into the top tier of your priorities. The moment you see a horizontal crack, it can be a 1 foot crack or a 2 foot crack, it can be 3 foot, it can just be 1 feet in a couple of locations. It is always important to make sure that the rebar behind this crack is still in serviceable condition. And if it's not, you have to replace it partially and make sure that your concrete is not losing its capacity to resist the forces that it is subjected to, especially the seismic forces. So that's why horizontal cracks usually top your priority list of items to address in a foundation.